Today's lesson is about the chain rule. So first we're going to look at this kind of discovery and using our knowledge of the product rule to differentiate. So I've got the derivative, or we want to find the derivative of x cubed minus 3 squared. So we're going to look at it as the derivative of x cubed minus 3 times x cubed minus 3. So I'm going to use the product rule. So we have our first and our second. Okay, the derivative of the first is going to be 3x squared. And the derivative of the second is going to be 3x squared. So we're going to go through and use that product rule. So 1 d2 plus 2 d1. So I've got x cubed minus 3 times 3x squared plus x cubed minus 3 times 3x squared. So looking at this, I've got essentially one bundle plus another bundle. So ultimately we have 2 of those, right, of our x cubed minus 3 times 3x squared. Okay. Just hit some equals there. So ultimately our goal here is to look at how do we go from x cubed minus 3 squared to 2 times x cubed minus 3 times 3x squared. Okay. So, right, we can see that we've got this kind of parentheses squared, right? And if I were to just look at that, right, and if I just take the derivative of something x squared, right, I drop the power and reduce by 1, right? So we can kind of see how that's going to show up here with that squared, right? And then on the inside, we've got our x cubed minus 3, right? Which we took the derivative and we saw that is this 3x squared. Okay, so now we're going to look at that chain rule, okay, that says the derivative of f of g of x, okay, this is a composition of functions, okay, so it's like one nested in the other, okay, right, so the derivative of f composed with g of x is equal to f prime g of x times g prime of x. Okay, I always think about it as like a present, okay? So we essentially take the derivative of the outside box, leave what's inside, and then we take the derivative of the inside. Okay, so let's look at this first one. Okay. So on this first one, my outside function is this something to the 4th power, okay? And our inside piece is our 3x cubed minus 5x. So something I can do is I can kind of think, right? This is my like thinking over here. That if I have something to the 4th, when I take the derivative, that's going to be 4 times that thing to the 3rd power, okay? And then for our inside piece, right, that's that 3x cubed minus 5x. Right, if I take its derivative, I'm going to get 9x squared minus 5. Okay, so I'm going to use kind of those colors again. So, right, this is my, like, inside piece. So the inside piece, inside piece. got our outside function, right? When I take that derivative, right, so we can see that derivative there. And then we've got that derivative of that inside function. So I'm going to try and color match this a little bit. So our derivative of f of x is going to be the derivative of the outside. So 4 times our inside cubed. Our inside, right, is still that 3x cubed minus 5x. And then we take the derivative of the inside function, so 9x squared minus 5. Okay, so let's add these colors in. So there's our inside derivative. Here's that derivative piece of the outside function. And there's my inside. Okay, and then of course we could go through and simplify this if we needed to. I personally would just kind of leave it. Okay. Okay, let's look at our next one. Number 2, I've got y equals sine 3 of x. So our outside function is our sine, okay? Inside function, 3x. Okay, so our y prime, derivative of the outside, so the derivative of sine is cosine, right? The inside stays there when I take that derivative of the outside, times the derivative of the inside, so times the derivative of 3x, which is just 3. So inside. Derivative of outside. Inside's derivative. Okay, so y equals sine of 3x. Y prime is equal to cosine of 3x times 3, which this one, right, I could kind of rewrite it. So 3 times cosine of 3x. Let's look at another one. Okay, number 3, g of x is equal to the square root of 2x squared minus x cubed. Okay, I'm actually going to rewrite this so that we don't have our square root and our power of 3. We're going to combine those. So 2x squared minus x is my inside, okay? The 3 is my numerator of the power now, and my square is the denominator. So I'm going to rewrite this as 2x squared minus x to the 3 halves. Okay. So that outside function is that something to the 3 halves power. Inside function, 2x squared minus x. Okay. G prime of x. Take the derivative of the outside. So, right, even if you need to like cover up what's the inside and just look at that, right? So it's something to the 3 halves. So drop the power. Write our inside function. Subtract 1 from our power. So 3 halves minus 1 is going to give me 1 half. And then times the derivative of the inside. So 2x squared minus x, so I'm going to take that derivative. 2x squared is going to become 4x, and minus x becomes a minus 1. So the g prime of x is 3 halves times 2x squared minus x to the 1 half times 4x minus 1. Okay, I'm going to color code that. There's our inside, derivative of my outside, and the derivative of the inside. Okay, a look at another one. H of theta is equal to 3 cosine squared of theta. So I'm actually going to rewrite it. So it looks like 3 times cosine of theta squared. Okay. 3 is a constant, right? So it's just going to kind of chill there when we take our derivatives. Okay. So h prime of theta is going to equal 3 times the derivative of the outside, right, which is my parentheses squared. So times, forgot my 2, so times 2 times the inside, so cosine of theta. 2 minus 1 gives me 1. And then we take the derivative of that inside, which is that cosine. Derivative of cosine is negative sine. Right, so I've got 3 times 2 cosine theta to the 1 power times negative sine theta. I'm going to simplify this. So negative 6 cosine theta sine theta. Okay. Go through color code a little bit. Actually, maybe I'll do the 3. We'll do it here. Right, and that 3 is a constant, so it's just going to kind of chill out front. Okay, next, number 5. G of x equals 1 over 2x plus 1, right? I could use the quotient rule here, or I can rewrite this function as 2x plus 1 to the negative 1 power, right? So that's using my exponent properties. If it's in the denominator, I can bring it up and write it as a negative exponent. Okay, so we can take our derivative. Outside function is that something to a negative 1. So when I take that derivative, I get negative 1 times the inside. Subtract 1, so I get negative 2. And then we take the derivative of our inside function, which is 2x plus 1. So its derivative becomes 2. So I get negative 1 times 2x plus 1 to the negative 2 power times 2. Okay, so I'm going to simplify this, right? So we can do negative 2 over 2x plus 1 squared. Color code. Right, and like I said, this one you could do the quotient rule instead. It's going to give you the same thing. Okay, so can kind of use both of those. Okay, next, number 6. F of x equals 3x squared times the cube root of 9 minus 4x squared. Okay, so I am going to rewrite my square root. Okay, so we're going to have 3x squared times 9 minus 4x squared to the 1/2 or 1/3 power, because it's our cube, right? So that's going to become the 1/3. So now we also have to use the product rule, right? I've got 2 things being multiplied. Okay. So we have the product and the chain rule happening here. Okay, product says I do first time and second, right? So let's product rule. So I'm going to write kind of these off to the side. So right, our first is 3x squared. So our derivative of the first piece is going to be 6x. Our second piece is that 9 minus 4x squared to the 1/3 power. So we have to use the chain rule for that. Okay. So that's my 1/3 times 9 minus 4x squared, right? So the derivative of the outside with the inside still there. 1/3 minus 1 gives me a negative 2/3. I'm also running out of room here. Okay. Let's move these guys. Okay. And then I have to take the derivative of the inside. So 9 minus 4x squared. The 9 is going to make a 0. So then I have negative 4 times 2. So it's going to give me a negative 8x because I reduced the power by 1. Okay. Now we have the two pieces. So product rule says we do the first. So the first is our 3x squared times the derivative of the second one. So 1/3 times 9 minus 4x squared to the negative 2/3 times negative 8x. Okay. Plus the second, so 9 minus 4x squared to the 1/3 times the derivative of the second, so 6x. Okay. Okay, and yes, ultimately you could go through and simplify this. For now, we're just going to leave that, right? But we can see our product rule in here, right? So this was our first times the derivative of the second plus the second times the derivative of the first. Okay, so we can merge those rules together. Okay, next, number 7, f of t equals sine cubed of 4t squared. Okay, this one I'm going to rewrite. So, sine of 4t squared cubed. Okay, so looking at this, our outside function is something cubed. We also have that sine, and we have picking a different color. Our 4t squared. So I actually have like 3 kind of functions nested in here. We're gonna do it the same way. Okay. So the derivative of the outside, inside stays intact. Okay. Times the derivative of the inside. So now I'm looking at that sine. Derivative of sine is cosine. Keep the inside. Times the derivative of the inside. So 4t squared gives me 8t. Okay. So see the derivative of our first outside piece, right? And then there's the derivative of our second piece, and then the derivative of our third piece, right? So it kind of just chains it out. So this is, if I had like f of g of h, right? We'll just call this, let's do b of x is equal to this function, right? So b prime of x, Derivative of the first, or the outside, times all the inside, times the next outside piece, times final inside piece. Okay, so you kind of got to break things up, right? And you take those pieces. Okay, let's look at number 8. It says, given this data, find the following. If f of x equals p of x times q of x, find f prime of 2. Okay. We've got a little multiply there, so that's going to mean the product rule. Right? So f prime of x is going to equal 1 d2 plus 2 d1. So I've got p of x times q prime of x plus q of x times p prime of x. We want to find f prime at 2. So I'm going to plug in that 2 into my little derivative we found here. And then I'm going to fill in this information from the table. So p of 2 is 5. So I have 5 times q of 2. Oh, wait, q prime of 2, sorry. Q prime of 2, which is 6. So 5 times 6 plus q of 2, which is 3, times p prime of 2, which is 7. Okay, just going to simplify that. 5 times 6 is 30. 3 times 7 is 21. So we get 51. Okay. Now let's go look at chain rule. Okay, we can see that we have that composition of functions, right? The q is nested in the p. And we want to find h prime of 2. So first off, we need to find out what h prime is, right? So it's the derivative of the outside. Inside stays the same. Times the derivative of the inside. So I've got p prime of q of x times q prime of x. I'm going to plug in our 2 here. So h prime at 2 is going to be p prime at q of 2 times q prime at 2. Okay. Well, I need to know what q of 2 is, which we already used, and that's at 3. So I'm going to have p prime of now 3 times q prime of 2, which was our 6 on the table. Okay. And p prime at 3, p prime at 3 is 8. So we're going to have 8 times 6, which gives me 40. Notice it says, you must quickly learn to distinguish between the chain rule and the product rule. Okay, so looking at pieces and determining like which option are we going to use. Okay, and a lot of times chain rule, right, we're looking for radicals, so square roots, cube roots, those kind of things. We're also looking for powers, okay? And we're also looking for like trig functions, right? So like example 2 and example 4 and example 7, right? Those all had trig functions that were usually our outside function, and we had a function that was a t or an x or a theta that was inside that. Okay, so that sometimes can kind of help you narrow down if you're using the chain rule or a product rule. Okay, good luck.